So this video is going to go over the two major definitions of acid-base that we use in first year chemistry. So you should be taking notes on this packet here that you got in class. I'm going to use same notes. I'm just going to give it to you in a different format. You might want to use a highlighter so that you can highlight certain things that I'm going to bring up. So there are two definitions of acids and bases. One is called Arrhenius acids and bases. So acids yield what we call H plus in aqueous solution. So acids are going to involve H plus. Bases are going to involve OH minus, and both of them are in what we call aqueous solution. So meaning when it's dissolved in water, they are going to be considered acid or base. So for our discussion, H plus is called hydrogen ion, and OH minus is called hydroxide. So if you start to see those words used in our discussions, you won't get confused by that. So most commonly used definition is Arrhenius acids and bases. So what you want to look for is if the first element is H, chances are it's going to be an acid. So HCl, HNO3. Sometimes you might see two H's, H2SO4. And then if you are a base, you could be anything with OH. So you can have multiple OHs, like with the second column on the periodic table, they're going to have two OHs to, again, get to a charge of 0. But again, that is going to be how you identify. That's probably the definition you're going to remember most when you leave chemistry. The second definition is called Bromonemori acids and bases. Again, you might want to pause the video and write it down. But acids are considered to be hydrogen ion donors, and bases are considered to be hydrogen ion acceptors. Again, this is a more comprehensive list or a comprehensive definition because not everything has OH when it is a base. So we needed different definitions. BronstedLowry encompasses more acids and bases because of that. Acid is going to be abbreviated A, of course, B is going to be abbreviated as a base. Another definition that you're going to need to know is H3O plus is called hydronium ion. So again, there's going to be some vocabulary words that you're going to have to be familiar with. So for Bromonemori acids and bases, you're going to have to look at an equation and figure out who is donating and who is accepting. So the way you kind of do Bromonemori acid-base definitions is an equilibrium reaction. So again, this is a reversible reaction. So we have HCl plus water becomes H3O plus and Cl minus. So these are going to be called pairs. All I want you to focus on is if you look at HCl, okay, what is it on the product side, meaning who is it becoming? So it's becoming Cl minus. What you could do is connect those two with a line to say that those are related. And then the H2O is becoming H3O plus, again, hydronium ion. So HCl is becoming Cl minus. So what you have to recognize is, are you donating an H? Or are you accepting an H? So since I'm losing an H to become Cl minus, this is my acid. I also know that H is listed first. That's generally going to be an acid. So if I'm looking at water, water is then becoming H3O plus. It is gaining an H plus to have that charge. So it's an acceptor. So this is going to be your base. Now realize one acid and one base will always be on the left. So acid base, base acid. But again, one has to be an acid, one has to be a base. You can't have acid, acid, you cannot have base, base. All right, so what is the other side of the equation is called the conjugates. These are a little more involved. So I'm going to give you a definition and then I'll show you with this example. So we have something called a conjugate acid. A conjugate acid forms when a base gains an H plus. So conjugate acid is going to be abbreviated Ca. Conjugate base is formed when an acid has donated an H plus. This is a Cb, okay? Generally speaking, Conjugate acids have a positive charge because they have gained an H plus. Conjugate bases tend to be negative, not always, but tend to be negative because they have lost an H plus. So that would make it, again, neutral. So over here, a base always becomes a conjugate acid, and acid always becomes the conjugate base. So if you connect the two, you know that this has to be the base, okay? And you're going to put a C in front of it to say it's the conjugate, meaning it came from this acid. So conjugate base, this has to be your conjugate acid. Also note, conjugate acids tend to be positive, conjugate bases tend to be negative. Acids will always have an H in them. This does not have an H, okay? So acid base, in my sense of the word, acid base comes down to H. Has it, who doesn't have it, is really all acid base is, okay? So with this as our example, okay, go to your example on the bottom there, where it says HF plus water becomes F minus at H3O plus. And then when you flip to the next page, there's this other one. NH3 plus water goes to NH4 plus and OH minus. So what you're doing is labeling on the left the acid and the base, and on the right, you're labeling the conjugate acid and conjugate base. So again, you can pause this video and see the answers in a moment. So in the first example that you have on the bottom of your sheet, HF is the acid. It has an H in it. It donates it to become an F minus, so it has to be the acid. So this is your conjugate base. Again, please understand there's no H there, so it can't be a conjugate acid. This then, the water is a base, so it's going to become the conjugate acid because it has a plus charge. NH3 is called ammonia. We talked about that with the Haber process. That is a base. It's reacting with an acid because NH3 is the one that is gaining the H plus. So it's becoming the conjugate acids. Again, you could kind of work backwards on this one, or recognize OH, no matter what definition, will always be a base. Okay, so the water has donated its H to the NH3 to become NH4 plus. And then the OH minus is then left over. So again, water is quite unique in the fact that it has a special term. It's called amphoteric. There are other substances that are acting this way, meaning they can act like an acid or a base, but water is the only one we are going to look at in this course. So you're going to have to know the term amphoteric. All that means is it could take on an H to become hydronium ion, or it can donate an H to become OH minus. So water is quite unique in the fact that it could do either thing depending upon what it's paired with. So going back to our example, if it's paired with an acid, it will act like a base. If it is paired with a base, it will act like an acid, is really how you get to know that. And finally, in this discussion of acids and bases, if you want to talk generalities of acids, they have certain characteristics. Understand that acids react with metals to form hydrogen gas. They react with bases to form water. So please understand that this last part is the same in both acids and bases. And that is where we're going to mix an acid with a base to neutralize it. That's going to be something we talk about a little bit later on. But again, bases do conduct electricity, so they are considered electrolytes just like acids are. There is absolutely no difference there. But their chemistry in terms of what they react with is different from, again, an acid. We've been using acids and bases all along, but now we're just kind of learning more about their characteristics. So that's the beginning part of our acid-base chemistry.